In this problem, we're going to use the ideal gas law. We are told that a 1.40 gram sample of nitrogen gas is added to an empty 4.0 liter container. We want to calculate the pressure inside the container at 22 degrees Celsius. To solve this problem, we need to use the ideal gas law. The ideal gas law is PV equals nRT. In this equation, P is the pressure of the gas in atmosphere, V is the volume of the gas in liters, N is the number of moles of gas, R is the ideal gas constant. Remember, this is the same for all gases and has a given value, and T is the temperature of the gas in Kelvin. In this problem, we are given the volume of the gas, the mass of the gas, which we can change to moles, and the temperature of the gas, which we have to convert to Kelvin. Rearranging PV equals nRT so that all of our known quantities are on one side allows us to solve for our unknown quantity. In this case, our unknown quantity is the pressure of the gas. Rearranging the equation yields P equal to nRT divided by V. Before we can plug any values into this equation, we must first convert all of our variables to the correct units. Let's start off by converting the grams of nitrogen to moles of nitrogen. Remember, nitrogen is a diatomic element. It always exists as N2. So the molar mass of N2 is 28.02 grams. We can convert 1.40 grams of nitrogen into moles of nitrogen. We'll then convert our temperature from 22 degrees Celsius to Kelvin by adding 273. We also know from the problem that the volume of the gas is 4.0 liters, and our ideal gas constant is 0.08206 liter atmosphere per mole Kelvin. We can now plug in these variables into our expression. Remember, the pressure is going to be equal to the number of moles of gas times the ideal gas constant times the temperature in Kelvin divided by the volume. So when we plug in our given quantities and solve for our pressure, we get a pressure of 0.303 atmosphere.